Hi, in today's lesson, we're going to learn the product rule of exponents. The product, remember, is the result to a multiplication problem. So if you're thinking about getting a product, you should be multiplying. So the product rule has to do with multiplying exponential expressions. Before we learn how to do that, we should know some key vocabulary. The first is base. You can think of the base as the bottom. Base, bottom, they both start with B. It's the number being raised to a power. So in 7, with a little 3, the base is the 7. The power is the little number. It's how many times the base multiplies by itself. So in 7 to the power of 3, the power is the 3. An exponent is another word for power. So once again, you're going to have that little 3 there. An expansion, so expansion is used with a lot of different operations. Basically, you're writing out without doing the operation. You might have done expansions of like just regular numbers, like 1,783 equals 1,000 plus 700 plus 80 plus 3. An expansion always looks longer. Expand is bigger. With exponents, when we expand them, we write them out as multiplication, and we don't write the exponent. So we're doing what the exponent does. So if you have 7 to the 4th, that equals 4 7s multiplied together. 7 times 7 times 7 times 7. This one is really important because if you forget any of the rules in this unit, you can do them by writing them out as expansions. It sometimes takes a long time, but it can be pretty easy. An equivalent expression always is another way to write an expression that is equal to it. With an exponents example, these two actually, 7 to the 4th is the same as 7 times 7 times 7 times 7. It's another way to write the same thing. It's another way to write the same thing. Both of those are equal to each other. But you could also say that 2 plus 2 is another way to write 4. Like, it doesn't really matter. Equivalent expressions can be across all operations. They just have to be equal. Equivalent means equal. The coefficient, we learned this vocabulary word a long time ago. It's the number multiplied to a variable in a term. It's usually at the front. So like in 3x to the 4th, the coefficient is this number and the exponent is that little 4 up there. Remember that terms they are basically separated by plus or minus. And when we're talking, sometimes it'll use words like monomial or binomial. So a monomial has just one term. A binomial, guess how many terms it has? It has 2. And then a polynomial, just like how a polygon has multiple sides, a polynomial has multiple terms, usually 3 or more. So you may be asked to identify terms, or it may say multiplying monomials. A monomial just means that there's one term, there are no pluses or minuses in the expression. Okay, so now let's learn how to do this. This is actually pretty simple. You might be so shocked at how simple this is. So you can only do this when you have the base being the same. So remember, the requirement is that they have the same base in order to do the product rule. But you can always tell by expanding and simplifying it out first. So we could write this as a being multiplied by itself 4 times a multiplied by itself 12 times. So let's write that out. It's going to take a while. We have 4 a's. I'm going to change colors for this so it's easier to see and count. Times 12 a's. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you could expand this out and then count how many a's there are at the end and then rewrite the expression as just one a to a power. So how many a's are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so this is a to the 16th. Now that way was pretty tedious. You might notice something that we did with the powers, and this will work every time that you're multiplying. You can, when you multiply two exponential expressions that have the same base, you can add their powers. So this is the same as a to the power of 4 plus 12, which equals a to the 16th. So you might want to write that in words. Add the powers. So now let's put this into practice. It gets a little harder once you add more things. So there's this one where we have g's. So I'm going to write g squared. That means there's two g's multiplied together. And then g to the 6th, that's 1, 2, 3, 4, 5, 6 g's multiplied together. And then we got this other g. I'm just going to add him on at the end. So when there's not a power, then the magic hidden power is 1. But you don't really need that 1 when you're writing it down, but it might be helpful when you're doing the product rule and you're adding the powers together. So let's count how many g's there are. I get 1, 2, 3, 4, 5, 6, 7, 8, 9, g to the 9th. And if you were to add all these powers together, you get 2 plus 6 plus 1 more equals 9. Remember to put that 1 on there if you're adding them together and doing the product rule and not expanding out. Okay, so now we're going to do exponent rules, and oh dear, this example has something other than just a letter with an exponent. So now we have a 5. I'm going to write this out just a little differently. I'm going to write this out as 5 times w squared times w cubed. Now, using my exponent rules, I know that I can only do the exponent rules to the numbers that have the same base. And the base is the bottom. Well, 5 doesn't have a bottom, but it is a bigger number. It's not a little number, so its exponent is 1. So we can only combine w with w squared and w cubed. So we're just going to combine those two. And then the 5 to the first doesn't have anybody to simplify with, so we'll just leave it the same. And I'm going to put 5 at the front. Now, your constants, your numbers that are not letters, should usually go at the front. That way they can be coefficients. And you can keep track of them all. It's also mathematical convention that if you have more than one letter, you usually put them in alphabetical order. So like 5xyz squared, put them in alphabetical order, and then we all get the same answer. It's still equivalent. Remember that word, equivalent expression? It's still equivalent if you say xzy, but we like to have them in alphabetical so we can compare our answers a little easier. Okay, now for this one, I'm going to expand this one out because it's a little easier, but if you were going to do the product rule, maybe try it and see if you get the same answer as I do. So I'm going to expand this one out. It's going to be 4 times A times 1, 2, 3, 4, 5, 6 B's times -7 times A and 3 B's. Okay, now I'm going to count up. Remember, we can only put the ones that are the same letter together. So I'm going to put the 3 A's I see together. So A, okay, and then the 1, 2, 3, 4, 5, 6, 7, 8, 9 B's together. Now 4 times -7, do I add those? Okay, the operation you are doing is 4 times -7. These do not have the same base. You cannot add these. This is an error I see a lot, that students are just like in adding mode. So they add 4 and -7 together. Nope, these are numbers, multiply them like numbers. 4 times -7 is -28. Okay, so when you did the power rule, did you get the same answer? I hope so. But remember what's important to do. If you're doing the power rule where you add all the numbers up, like you would just add 6 and 3 to get 9, you're going to want to write a 1 as the power of all your bases that don't have powers already. Then your product rule will work. All right, that is all. Good luck.